So, good afternoon. Almost good evening, but still afternoon. Today I'm happy to discuss with you all HashiCorp's policy as code framework, Sentinel. Whether you're new or completely new to Sentinel or not, I hope this presentation can get you more familiar with the framework and its role in our enterprise products. I'm Chris Marchesi, engineering lead for Sentinel at HashiCorp, and the primary developer for the Sentinel runtime and its integrations, namely Terraform Cloud and Enterprise. So, let's start with a brief on what Sentinel actually is. Sentinel is HashiCorp's policy as code framework. We introduced it about a year and a half ago at HashiCorp 2017, maybe almost 2 years ago now, or HashiConf 2017, excuse me. It enables IT governance in HashiCorp's enterprise products. You'll see integrations in Terraform Cloud and Enterprise, Consul Enterprise, Nomad Enterprise, and Vault Enterprise. Today, I'd like to give you all a general tour of the framework to help you, the practitioner, get an idea of the problems Sentinel was designed to solve, how it works with our products, and how you can get started using it today. So, what exactly do we mean when we say Sentinel is a policy as code product? In order to better explain what policy as code is, let's start by building some context and discuss a well-established concept of infrastructure as code. This will give you a foundation on which we can build, and make it even more obvious as to why policy as code is necessary to work with IaC at scale. At HashiCorp, we're firm believers of the concept of infrastructure as code, and we'd like to think that our products embody the practice. We believe that investing in IaC is necessary for an organization to scale. It can be very rewarding in its own right to practitioners of a wide variety of backgrounds. Let's dive a bit more into what we mean here by discussing how IaC helps by versioning your work, providing automation for your workflows, and providing natural documentation for your processes. While not necessarily the whole of IaC, we believe that these disciplines are at the heart of the concept. Let's start with versioning. Versioning is the foundation of the infrastructure as code concept, giving you configuration storage with history. It's a practice of using VCS systems, such as Git, to store configuration data. And these changes are tracked. The VCS history will tell you who made any change, exactly what they changed, and when they changed it. And this means that a natural audit trail is produced. Now, this all allows for the observation of changed infrastructure over time. A VCS system, while generally designed for developers, turns out to be a great way to ensure systems engineers can keep track of the modifications they're making, keep them on hand for backups or redeployments, and roll them back if need be. So next, let's move on to automation. The object of automation in IaC is to support a simple deployment workflow to complex infrastructure. Automation is important as it ensures IaC provides value over basic documentation and manual procedures. And what we mean with automation here is we transfer manual workflows to automated ones. And we aim to execute deployments in a single operation, or at least aim to reduce the number of steps required. And this process vastly reduces the amount of manual work necessary and reduces the possibility for human error. And ultimately, automation enables us to deploy at a scale not normally possible with human work. Extremely complex operations that would normally take hours can take minutes or even seconds, and entire workflow can now be repeated hundreds or thousands of times trivially. And finally, let's talk about documentation. I'd be hard-pressed to think of any organization that's perfect with theirs. All too often, workflows adopted by individuals may go undocumented because since writing good documentation takes time, and it's highly susceptible to drift as situations change. Now, IaC solves this problem by making the source the documentation. And while usually said tongue-in-cheek as a criticism in software development, it actually works quite well when applied to infrastructure. This is because it reduces or removes the need for documentation that may be prone to frequent change. It also reduces the risk of divergence of documentation from reality, and can largely replace documentation when it concerns automation. Every HashiCorp product implements the concepts we've just discussed to some degree. As IaC tools at heart, Terraform, Packer, and Vagrant are industry leaders when it comes to provisioning a multi-cloud infrastructure, images, or development environments. And while Consul, Nomad, and Vault are not specifically IaC tools themselves, their designs still make it easy to version configuration, automate management, and self-document their particular problem domains. So now that we have some of the background of infrastructure as code, let's take a look at some of the challenges that may arise when applying these principles to large organizations. Infrastructure as code is great because it allows you to scale. It reduces the barrier to entry through automation, in addition to just flat out allowing people to do more. But as an organization scales, IaC presents its own challenges. The increase of productivity inherent in automation makes risk management harder. It can put pressure on the teams who are responsible for managing risk within the organization. This can make it hard to effectively manage the security of the infrastructure in the organization, ensuring that the organization is in compliance, and ensuring workflows follow best practices. Let's look at why these things are important. Let's talk about security first. Security is a fundamental and important part of every organization. As an organization scales, there's always the risk that security policies and procedures may get lost in the growth. Security awareness is also subjective from employee to employee. Through no fault of their own, an individual may unintentionally perform an action that could expose the organization's infrastructure to vulnerabilities. Even security awareness training may not account for every scenario, most notably good old-fashioned human error. And security lapses at scale can have extremely disastrous results. Data breaches at large organizations are usually newsworthy events, with possibly millions of clients being put at risk, causing damage to a company's reputation that can usually take years to repair. And hand in hand with security is compliance. Security and privacy procedures usually take the form of industry-mandated security and privacy procedures. Examples include payment processing standards, such as the PCI DSS, various government standards, such as the FIPS standards in the United States, and data privacy standards like the GDPR. Violations of these standards can affect your business, violate PCI, and you could lose your ability to process payments. Violate the governance standards, and you could lose access to entire business sectors. And violate GDPR, and you could face fines and financial penalties, sometimes in the tens of millions of euros. All practitioners should be aware and receive the appropriate training, but as with security, not everyone's going to have the same level of awareness and in general regarding these sensitivities. As an organization grows, it becomes increasingly harder to manage this at the human level. Finally, there's the concept of best practices. These aren't necessarily hard and fast security policies or privacy standards like the GDPR. These are just things that are generally correct procedures not covered by a specific standard. But examples here would be to say, not set up single points of failure, optimize for cost efficiency, or build for a responsive user experience. But best practice can be a problem. I personally actually have a problem with the term, because best practice and common sense are used interchangeably way too often. This can lead to assumptions about an individual's awareness. I mean, you could easily replace its best practice with it's just common sense when talking about these three things. And after the fact, usually in things like a post-mortem, hindsight's very much 20/20 here. And these problems are aggravated at scale. As an organization takes on individuals and employees, you're going to have a lot more opinions as to how it actually constitutes best practice. So, how do we solve these policy issues? How do we make sure that we aim to eliminate the assumption that everyone knows how to configure a redundant or performant infrastructure that adheres to industry standards and government regulations and doesn't make the organization vulnerable? Let's talk a bit about policy as code. So let's talk about a traditional process first. This is mainly the process of using documentation for manual review. In the manual process, security, compliance, and best practices are usually stored within documentation as policies to be followed. These are then applied by practitioners during code review and dry runs, such as reviewing the output of a Terraform plan. When we refer to manual application, we're saying that the reviewer follows the policy when making judgments on whether or not to allow a change. The problems here, though, are threefold. First off, code review is a labor and requires context. And this can be tough if the experts for the code review are on one team, and like the domain experts for security and compliance are on another. Reviews take enough time already, and this can just exacerbate things. And second off, errors can be missed or subjectively accepted as correct. No one reviewer is the same, and it sometimes can be a number of factors in play in addition to the aforementioned context issue. And finally, review can take days and lead to frustration, mainly due to these factors, but possibly others. This can be a disempowering process for the practitioner and risks negating the gains that adopting infrastructure as code gets you. So this is why policy as code is important, because moving your policies out of documentation and into code allows you to automate these checks and balances, remove arbitrary interpretation, supply immediate results for engineers, which ultimately means everyone can get back to the work that they enjoy doing. And further to that, our policies now enjoy the same benefits as our infrastructure code. You store them in VCS with a change history. You automate your policy checks as part of your regular workflow. And finally, you document your policies with code, replacing a good part of your on-paper policy. So let's talk about the things we've been trying to do with Sentinel at HashiCorp to help make policy as code a good experience for everyone. Our objective when designing Sentinel was to bring infrastructure and code principles to the governance, risk, and compliance field. This meant bringing over a lot of people that weren't programmers. So as such, we aim to make a programming language that's friendly to both non-programmers and programmers alike. In addition, we aim for Sentinel to be embeddable, so that it's easy to integrate into all of our products, safe, so that it can be executed in a sensitive context, and finally, auditable, so you know which rules passed or failed and why. Let's elaborate on these fundamentals. First off, we aim to design Sentinel in a way that programming experience isn't required to work with the product. As just mentioned, we're working with an audience that's composed significantly of non-programmers. They may be operations people or compliance experts, or maybe just systems engineers. As practitioners of Sentinel, we want these audiences to be able to understand the policies written within the language and actually be able to write them with a level of proficiency. So we aim to keep the language easy and understandable by a couple of principles. The first is an emphasis on simple policies. The language and integrations are extended with the objective of keeping policies short and readable. In addition, we like to restrict policies to a single file of code so that if a policy gets too large and too unwieldy, that kind of tells us that we actually need to start working on our integrations better and things like that to get it back to that principle. And secondly, we use an English-based grammar. Most statements, keywords, and operators are English language words, structured in a way that reads something between pseudocode and actual English language sentences. At the same time, we still aim to make Sentinel friendly to programmers. Stakeholders with programming or even at least scripting experience will be able to write more complex policies than those that don't have a similar background. Sentinel has constructs that any programmer would reasonably expect, such as conditionals, loops, and the ability to create functions to help with more complex workflows. The Sentinel Simulator also has advanced testing and mocking features that we'll cover later in this presentation. These features allow practitioners to mimic the environments that they'll encounter in production to ensure policies function correctly. And to help with processing the wide variety of data you encounter in Sentinel, we also have a growing standard library that we're building on all the time. Some of the imports available in the standard library include the time import for accessing time of day and stuff like that, the JSON import for parsing JSON data, and the strings import for working with the many kinds of strings you'll get. These aren't all of the imports, of course. You can find these and more on the Sentinel website. Now let's talk a bit more about how we design Sentinel to be embeddable and safe into the products it's integrated into. Internally, we designed Sentinel with this principle of straightforward integration into HashiCorp products. It's actually embedded directly in the enterprise binaries you get with Consul, Nomad, and Vault Enterprise. With Sentinel being invoked in time-critical places in these products, we've designed it to be efficient and minimize impact to the request path. This level of embedding also means we need Sentinel to be resilient and safe. We've designed a broadly read-only language and runtime model. The purpose of Sentinel right now is generally to analyze data and not really change it. We also give restricted system resources to the runtime. This prevents Sentinel from actually crashing the system that it's embedded into. And there's also no ability in the runtime to execute arbitrary commands. And finally, Sentinel is designed to be auditable, so you knew what rules passed or failed and why. Trace data is retained for rules, including any subrules and conditions that triggered a specific result. The data is built naturally as rules are evaluated in a policy. This promotes a more granular pattern for policy authoring. We encourage authors to write policies with many small rules to take advantage of auditing functionality. So Sentinel's been implemented in every HashiCorp product at varying levels of scale, but has probably seen its most extensive deployment to date in Terraform Cloud and Enterprise. Let's take a look at each of these implementations, including what a policy may look like in each implementation, and some of the features that are offered with Sentinel in each of these products. Here's an example of what a policy looks like within Terraform Cloud and Enterprise. In this example, we use data from a Terraform plan provided by an import that provides the plan data, which is aptly named tfplan. This example would traverse all AWS instance resources defined in the root module and ensure that all instances have tags defined. If a resource is detected that doesn't have tags, the policy is failed and the run is blocked. Sentinel policy checks run in Terraform Cloud and Enterprise immediately after the plan has been made. This phase, called the policy check, is sent the plan along with any configuration and any existing previous state. You make a policy based off of this data, with the results ultimately determining if the plan can or cannot proceed. You can also use a soft mandatory result to require that a plan proceed only with approval from an organization administrator. Policies are organized in Terraform Cloud and Enterprise by way of policy sets, which we just recently updated to adopt a completely VCS-hosted pattern. Policy sets now function very similar to workspaces in that policies are ingressed as they're added or modified on the source VCS repository. You choose to apply these policies to specific workspaces or to the organization as a whole. When a run executes, policies from all applicable sets are collected and sent for execution in the policy check for that run. Which policies are executed, along with each of their enforcement levels, are configured from within an HCL-based configuration file in the policy set repository. And being able to test your policies before they get deployed to a policy set is an important part of the development process. Testing policies live can be tedious, so we provide the tools to allow you to test policies offline before deployment. And again, we'll discuss testing in detail a little later. An important part of offline testing, though, is the ability to work with mock data. And the data that comes from Terraform Cloud and Enterprise can be in particularly complex, and mocking each particular scenario can be hard without access to actual data. To help ease this, we allow the capability to generate mock data off of any existing Terraform plan. Whether you need an additional data set to work off of, or you need data to account for a certain scenario, mock generation gives you the confidence that you'll be working with exactly the data that you need to work with. And finally, let's discuss some upcoming features that will be coming in Terraform Cloud and Enterprise for Sentinel. The first is what we're calling the workspace metadata import. This will complement the current Terraform imports by giving you access to specific data beyond the simple config planner state. This will include data specific to the workspace, run, or organization. For example, you can change policy behavior based on the organization or workspace name that it was a part of. The second is the integration of cost estimation data into Sentinel. Cost estimation is something that we're currently working on. It's actually in beta right now. But when it gets into Sentinel, you'll actually be able to make policy decisions based on the cost of executing a plan. Lastly, we'll be working to reduce the burden on workspace management by allowing automatic policy set association with workspaces. Through rules defined on a workspace, policy sets will be automatically associated with workspaces as they're added, or even as the rules change on a policy set itself. So now let's see what a policy looks like in Vault Enterprise. Sentinel support in Vault Enterprise that complements the existing ACL system with the addition of 2 new types of policies. Role governing policies, or RGPs, are tied to particular tokens, identity entities, or identity groups. Endpoint governing policies, or EGPs, are tied to paths instead of tokens. During a specific request in Vault Enterprise, all 3 policy types are evaluated, starting with conventional ACLs, and then moving on to the Sentinel RGPs and EGPs in that order. The first 2 policies are only evaluated if the request is authenticated, which means that Sentinel and endpoint policies are the only way to perform policy checks independent of authentication data. And here, we have an example of an EGP demonstrating the instant invalidation of all tokens that have been created before a specific time. This can be used as a kill switch of sorts in the event of a large-scale compromise to ensure that no old tokens are allowed, buying time for forensic analysis and targeted remediation. Similar measures in the conventional ACL system would require that a policy can be modified so that it's attached to every token, in addition to being not applicable to otherwise unauthenticated paths. Now let's move on to Nomad Enterprise. Sentinel policies in Nomad Enterprise allow you to hook into the job management process during operations such as job creation or modification. Access to the job structure is given, allowing deep introspection into any job configuration file. In addition to this, Nomad Enterprise allows or fully supports soft mandatory policies. When the appropriate capability is assigned to a user, job submissions that would normally fail can be forced to proceed by supplying the policy override flag in the Nomad CLI or via the parameter in the specific API request. Here, we have a policy to ensure that all task groups in the job are using Docker drivers, blocking any other type of job. This would ultimately mean that all the jobs run with this policy have to be Docker containers. And finally, we have Consul Enterprise. Sentinel support in Consul Enterprise extends a standard ACL system for the key value store past the standard read, write, and deny policies, allowing full conditional logic and access to the data being written. Here, we have a policy that checks the key being written to and validates the input. If we're storing the port, it must be an integer, and if we're storing the name, it must be a word, so really a contiguous series of Unicode characters, digits, and connectors. And to close out the discussion today, let's talk a bit about the Sentinel Simulator. The simulator packages the entire core runtime into a CLI tool that assists in developing and testing Sentinel policies. Whether you're an existing enterprise customer or a practitioner looking to give Sentinel a try, the simulator is an important part of your workflow. Using the Sentinel Simulator, you can try out sample policies with the apply subcommand to see if they pass or fail. Here, we try a simple policy that tests a time standard import. As the simulator comes with a standard library, it's great for these kinds of things. You can use it to play with the standard library all you want. The simulator wouldn't be entirely effective if it was just able to utilize the standard library. As such, the simulator has capabilities that allow you to simulate the environment seen in HashiCorp's products. Here we see a basic example that verifies a simulated import. The data is supplied as a static object within the JSON configuration file. In addition to being able to supply mocks as static data, the Sentinel Simulator also provides the ability to supply mocks as Sentinel code. This allows you to mock data that JSON can't actually represent, or other features such as functions. Here's an example utilizing the previously mentioned mock data supplied from Terraform Cloud Enterprise. We actually don't show you the contents of the mock file because they're generally pretty large. Instead of the object, though, you'll notice that the path to the mock data file is supplied. And utilizing this more powerful mocking feature is crucial to the accurate mocking of Terraform data and the entirety of the import. And finally, I'd like to take a little bit more time covering the Sentinel Simulator's testing feature. The Sentinel Simulator can be used to conduct sophisticated testing comprising of multiple policies and tests across the repository. Here, we've laid out an example repository with 2 policies. And within the repository, you can see the test directory, and then there's 2 subdirectories under there where we place the tests. Here, we have a passing and failing test for each of the policies shown. Each configuration file can not only assert different results for specific rules, but can contain different configurations for mock data, ensuring that you can test your policies against as many scenarios as needed to be assured that your policies will behave as expected. This is a passing test, but the import mocked as expected by the policy, and an assertion that the main rule will return a true result. For a more sophisticated policy, you want to add all the rules in their assertions. As mentioned, you can mock the data as you see fit for each test case. This is the failing test, where we've adjusted the mock data so that the policy will actually fail, and then we expect this, which can be, you can see there as asserted by false in the main rule. And to run the entire test suite, you just run Sentinel test. This will run the tests for all the policies that are found in the working directory. Being able to test not only against multiple cases, but also multiple policies at once in a single repository is especially useful when working with things such as policy sets in Terraform Cloud Enterprise. The Sentinel Simulator is free to use and available on the Sentinel website. And it's available to use on all major platforms, including Windows, macOS, and Linux. And that's it. If you'd like to learn more about Sentinel, you can read all about it on our documentation page at https://docs.hashicorp.com/sentinel. If you'd like to know more at the conference, feel free to come by one of our booths tomorrow. And if you're interested in getting a more in-depth demo of Sentinel on any HashiCorp product, you can contact sales at https://www.hashicorp.com/go/sentinel-demo. Again, I'm Chris Marchesi, engineering lead for Sentinel, and it's been my pleasure to present this to you today. Thank you.